Let us take in strength of material. In today's class, we will discuss about types of stresses. Say, according to the direction of force, we can say what type of stress the object is subjecting. So, the direction of force is very important. Force direction is very important as well as the given magnitude. So, it has both magnitude and direction. So, we can call it as vector quantity. Okay, if you are taking distance, let us take it is 5 meters, 6 meters, like that. The magnitude is important for this, not the direction. Whenever we are telling 5 meters distance, we are not giving the direction. Okay, so that's why it has only magnitude. Magnitude means it is a scalar quantity. The another example of scalar quantity is pressure. So pressure also we are giving the magnitude 25 bar, 30 bar, like that. We are not giving the direction for it. Main important points. What are the types of forces? Okay, so here I did some diagrams. Okay, so in these diagrams, in some cases I'm applying the force is like this. Okay, in the first case I'm applying pull type force at both sides, same magnitude. Okay, this force is called tensile force. Okay, so if the force is push type, this force is called compressive force. Okay, here in the pull type I am applying the force perpendicular to the surface. In push type also I am applying the force perpendicular to the surface. This is the surface. Okay, I am applying the force along the axis. Here also I am applying the force along the axis. Okay, this is called tensile force, this is called compressive force, and then here I am applying the force parallel to the surface. This force is called shear force. Okay, along the surface we are applying like this. And then next force is, here I am applying, this is the given body, I am applying some force on it. At both sides two supports are there. Because of this force, this body is bending. So this force is called bending force. Here what we are doing, in next case the body I am twisting. Okay, one clockwise force and another is anti-clockwise force, or vice versa. So here this force is called torque or torsional force. So this type of forces we can apply on any body, given body. Okay, and here because of this pull type, that is tensile force, the body will try to elongate. Okay, the distance it will elongate. Let us take L is length of the body, it will elongate delta L because of application of force. Okay, so stress will develop inside it. It is called tensile stress. Okay, here I have written the stress developed inside the body is called tensile stress. We are taking the symbol sigma T. Sigma, where sigma is stress, T indicates the tensile. And here the force is perpendicular to the surface. And one more thing is, force is acting along the axis. That's why whatever stress is developing inside this, we can call it as axial stress also. Okay, because applied force is acting along the axis. So we can call it as either tensile stress or axial stress also. Okay, here how to take the axis, this body has two axes. One is axis is horizontal, the another axis is vertical. For any object, two-dimensional object, it has two axes. Why we are taking this axis means, always remember whatever surface we are taking this surface, we are applying the load on it. So we are taking this surface. Axis should be always perpendicular to this taken surface. Axis is always perpendicular to the taken surface. Okay, and that's why we are not considering this axis. Okay, so here force is acting along the axis. Okay, in this body, because of this push force, the stress will develop inside it. It is called compressive stress. The symbol we are taking, stress is sigma C we are taking. This object will compress. Okay, it will compress along its length. Whatever dimension we are taking, it will compress. Here also force is acting along the axis. So this compressive stress we can call it as axial stress also. Here the applied force is perpendicular to the surface. We are applying the force, shear force, parallel to the surface. The stress developed inside the body is shear stress. Okay, because of this force, the body will try to come, if you are taking in terms of layers, all layers will go this side, and here whatever layers are there, they will go this side. Okay, it is like steps. Okay, like this. So the body is subjected to shear stress. The symbol we are taking tau. Here, which axis we have to take? Horizontal axis or vertical axis? As I told initially, whatever surface we are taking, the axis should be perpendicular to that surface. Here we are taking this surface. So we have to consider this axis, vertical axis, because surface and axis should be 90 degrees with each other. Okay. So for here in these two cases, forces are acting along the axis. But here force is acting perpendicular to the axis. Okay. So whatever stress is developed, it is the shear stress. Okay. And then next one is it is simply supported. If you are applying the load at both ends, it is called simply supported beam. Okay, here I am applying the force, bending force. Because of it, the body will get this shape. Okay, in it some stress will develop inside the body. This stress is called bending stress, sigma b. Axis we have to take, it should be like this. This axis we have to take. Okay, we will discuss in next classes how to consider all these axes. And then for bending stress we are taking this formula. We will discuss in next classes. M by I is equal to sigma B by Y, where sigma B is the bending stress. Next case, the body I am twisting. Okay, one clockwise force and another is anti-clockwise force, or vice versa. So here this force is called torque or torsional force. So whatever stress will develop, it is called torsional stress. We are taking sigma T for this. Okay, calculating the torque. Okay, and here the stress will develop the shear stress. So because of it, we can find Fs is equal to torque into radius divided by J. Twisting, the body will twist about the axis. Okay, these changes will occur because of these forces. If we see the classification of stresses or types of stresses, we can write here, we can divide these three into direct stresses and these two in indirect stresses, and next type is combined stresses. There are three types of stresses. Okay, if you are taking indirect stresses, we are applying the force on a given body directly. So stresses developed inside these are tensile force, because of tensile force, tensile stress will develop. Because of compressive force, compressive stress will develop. Because of shear force, shear stress will develop. These three are the direct stresses. Means with direct force, direct stresses will develop inside the object. And if you see the next category, indirect stresses, means here forces we are applying directly on the object, okay, on a given body, but stresses, bending stresses and torsional stresses will develop indirectly. Because of direct forces, indirect stresses will develop. Those are called indirect stresses. Okay, and then next one is combined stresses. Combined stresses means direct forces we are applying. Okay, so sometimes they are getting both bending stresses and torsional stresses. It is called combined stress. In all these three cases, the force we are applying on the body is direct force, but the stresses developed here directly. Okay, in these three cases, here stresses will develop, okay, indirect to the direct force. Here in combined, both bending and torsional stresses will develop. Okay, and we will see next classes all how to find out the tensile stress, compressive stress formulas. We will see.